So we are looking at concept 20.1, which is geometry surface area. In this first set of problems, what you're asked to do, let's scroll this down so we have a little more workspace. You are asked to compare the surface area of the two figures given. On the left, you have a triangular prism. On the right, you have a rectangular prism. One of the things that we have found is really helpful when doing surface area is to start out and look at the figure and determine how many faces there are. So for this figure, we have two triangular faces. We have a rectangular face on the bottom. We have a rectangular face on the side. And we have a rectangular face in the back. So for this particular figure, there are 5 faces. Of those 5 faces, 2 of them are identical. The 2 triangular faces are identical. So let me go ahead and get rid of all of that extra writing. And let's go ahead and figure out the surface area of this figure. So here's what I know. I know I have 2 faces that are the triangular faces. Now remember, area of a triangle is base times height. So 12 times 16 divided by 2. Let's pull out our calculator. Again, remember, we use real tools for real problems. So 12 times 16 gives me a total of 192 divided by 2. This is each face, by the way. So what I'm calculating right now is just the area of that triangle. I'm not doing both ends yet. I know I'm going to have 2 of these eventually, but right now I just have this first one that I'm calculating. So let me finish that out. So then I have the 192 divided by 2 has an area of 96. So this has an area of 96 meters squared. I need 2 of those. So I'm going to have that 96 times 2 gives me 192. That's 2 of my 5 faces. 5 faces. All right, the next face, I'm going to have 1, and I did the bottom. So let me go ahead, let's get rid of all of that. And now, let's see, we'll take and we'll just put this shading, that was this. Okay. So now I'm going to find this face. And that face is base times height, 18 times 20, and 18 times 20 is 360, and there's only one like that, so I'm going to bring that 360 all the way over. All right, now, and by the way, let me go back for just a minute. When I got that 192, that 192 was both of those faces because I multiplied by 2 to get them both. All right. I wish I had 6 of these figures so I could show you each one individually, but we're going to have to work with what we've got. All right, next I'm going to find this face, this bottom. So for that bottom, I'm going to have one face that is 12 by 18. So 18 times 12, or 12 times 18, its multiplication order doesn't matter. 216, there's only one of those. Bring it over. Finally, let's get rid of this. Finally, I'm ready to find this face in back. So I've got this back of the figure, and that is 16 high and 18 wide, or 18 long. This 18 is also an 18 right on that piece, or could be an 18 up on this piece. So I'm going to have one more face here, and that's this orange face that I'm doing. So I've got the orange face, and that's going to be one face that is 16 by 18. So 16 by 18 for a total of 128. Bring that over, 128. And now I'm going to add all of these together. So I have the 128 plus, I have a 216 plus, I have a 360 plus my two triangular ends altogether, 192, and I get 896 meters squared. It's an area problem, so surface area is always meters squared. That's my first figure. Now I need to get my second figure to compare it to. So let's move my calculator. Let's get the calculator all the way out of the way for just a minute. Now I've got the second figure. And for the second figure, I have a total of 6 faces. I have this end, and there's one just like it there. I have this top, and there's one just like it on the bottom. And I have this side, and there's one just like it on the other side. So this problem has 6 faces. It's actually easier to solve because those faces all come in pairs. So I only need to calculate 3 faces and then double each of them. So let's get rid of all of that because it makes it kind of hard to see. And let's do them one at a time. The first face I'm going to do is right here. And for that face, I know that I have 2 faces. Each face is 5 times 15. So 5 times 15 is 75. So I know that I have 75 twice 150. And I know twice because that face and this face are both 5 by 15. Next, I've got this face, which is also this face. And each of those faces, there are 2 of them, and each of those faces is 5 by 25. And 5 times 25 is 125, so I have that 125 2 times, which gives me 250. All right, lastly, I have 2 faces that are this edge, or this side, and this side. And each of those is 15 by 25. I can see this 25 on the bottom also becomes a 25 right there. Or another way to look at it, that 15 becomes a 15 right here. However you want to see it, I have 2 faces. Two faces that are each 15 by 25. I'm going to use my calculator for this one. All right, 15 times 25. So each of those is 375. 375 times 2 is 750. And when I add all those together, 750 plus 250 plus 150, I get 1,150. So this is 1,150 150 meters squared. This is 896 meters squared. And so this is less than. Okay, so you've seen that first one. Go ahead now and try the bottom. And if you haven't already completed the bottom problems, there they are. Pretty similar stuff. If you haven't completed it yet, do it now. If you weren't sure, you've watched the video, you understand some things you didn't understand before, go ahead and do this now. Pause the video and then come back to it when you're done. All right, we're back. We're figuring that you have solved both these. So this first problem, it's a triangular prism. Every triangular prism has 5 faces. In fact, I can come over here right now. Since it's a triangular prism, it will have 5 faces. This first triangular prism has a triangular face that is 12 by 8 divided by 2. And another one at this end that's also 12 times 8 divided by 2. So to solve those two, I'm solving these two right now. I solve those by doing the base 12 times the height 8 divided by 2. And let me just bring this over a little bit because I want to keep the same idea I was doing before. I have 2 of these. So I have 2 that are 12 by 8 divided by 2. 12 times 8 is 96 divided by 2. 96 divided by 2 is 48. And I have 48 twice back to 96. Sometimes students say, well, why do you show that? Why do you divide by 2 if you're just going to multiply by 2? Because I want to know that this 48 is just this face right here. And that 48 is just that face right there. And then I get those two together to get the 96. All right, the next face, let's get rid of this and this. And the next face that we're going to do is this face that's 15 by 10. And there's one on the other side that's also 15 by 10. Both of these have diagonals of 10. So that works out well for me because what it means for me is that I get to have 2 faces that are 15 by 10. So 2 of my 5. 10 times 15 is 150. 150 times 2, 300. Then lastly, so I'll just take my 300 and put it right on this face. This was 300. Oh, excuse me. Let me do that correctly. That face isn't 300. That face is 150. I'll put the 150 right here. So lastly, I've got the bottom. The bottom right here, there is one face like it. And that one face is 15 by 12. Let's grab our calculator. 15 times 12, 180. I don't have 2 of those. I have just one of them, so I bring that 180 right over. And then I start adding things together. So I have my 180 plus the 300 plus the 96. I have 576 square meters. 576 square meters of surface area on that first figure. All right, for the second figure, let's get the calculator out of the way. We won't need it for a moment. The second figure also has 5 faces, and just like the last time, let's do the triangle first. So it has a triangle at this end and a triangle at that end, and each of those triangles, there are 2 shapes like this now. So we have 2 faces, And each of those faces is base times height divided by 2. So 5 times 12 divided by 2, which is 60 divided by 2, which is 30. And I have that 30 twice, so I have 60. I'm afraid I'm right at the edge of my screen. Let me bring that back just a little bit. Let me bring this whole thing over just a little ways. Okay. So put a line down to separate these two. All right, so my triangles total 60. Then I have, let's get that gone so we can see the next one. Then I have a face right here. That face is 5 by 14. So I have one face that's 5 by 14. Where's that calculator? Hey, where is it? There we go. So 5 times 14. That face is 70. There's only one like it, so I can bring the 70 right over. All right. Next, get you out of the way there, calculator. Next, I have a face. I'll erase this. I have another face that is right here. It is 12 by 14. So this 14 also is that 14. So I have a face that's 12 by 14. There's one of those, one face, 12 by 14. So 12 by 14 for a total of 168. I need to scroll just a little bit so we don't lose our work on this problem. And then finally, let's bring that 168 over. 168. And then finally, we have a face right here that is 13 by 14. So we have one face that is 13 by 14. So it's just a 14 more than that. I think that's 182. Let me just check it though. 13 times 14. Yeah, 182. Bring that over. And let's add those all together. So the 182 is still in my calculator, plus a 168, plus a 70, plus a 60 equals 480 meters squared. 480 meters squared. And this problem, therefore, works out to be greater than. 576 meters squared is greater than 480 meters squared. All right, you are ready to do concept 20 now. So again, look at this. Since it's concept 20, you found it on test 20, also on test 21, and on test 22. So go back, review some of your old tests, and as soon as you feel like, boy, I really know how to do this, come and see me and we'll schedule a time for you to take an intervention test.